Hello children, welcome to aimsindia's online classes. In today's video, from physics subject, measurement topic we are going to continue. Let's learn about dimensions in this video children. Dimensions. Here dimension means the nature of a physical quantity is described by its dimensions. So what is physical quantity? Which can be measured. The quantity which can be measured by physical instruments is called a physical quantity. What are the physical quantities we have? Length, mass, time. These are the fundamental physical quantities which never depend on other quantities. We have quantities like momentum or force or velocity or volume. Like this, other quantities are there which depends on fundamental quantities, and they are called derived quantities. So physical quantities, two types are there. Fundamental quantities like length, mass, time, which are independent. Derived quantities which depends on fundamental quantities. So all these fundamental quantities and derived quantities, their nature described by the dimensions. Here the fundamental quantities, they are also called as base quantities. They are also considered as base quantities. So dimension means it tells about the nature of any physical quantity. It may be fundamental or it may be derived. Its nature will be described by the dimensions. Actually, these dimensions, they are the powers. They are the powers to which base quantities are raised to represent the given physical quantity. So dimensions means they are the powers or they are the exponents to which base quantities are raised to represent the quantities. So that suppose if m is there, m is a base quantity. So m power 1 or m1. In this m1 means in that quantity mass appeared for one time. In this m is the base quantity, 1 is the power. This power is called dimension. This power is called dimension. So the quantity, the physical quantity that is expressed in terms of base quantities to be enclosed in this square brackets. To be enclosed in square brackets. So let's try to understand with one example, children. Suppose if we have density. Here density is a physical quantity or density is a derived quantity which depends on mass and volume. Because density formula is mass by volume, so it depends on mass and volume. Volume formula again, LBH, length into breadth into height, or length into breadth also one kind of length, height also one kind of length, which is again mass to be kept same, but volume can be converted to length cube, L into L into L, L cube, length cube. If this length cube go to numerator part, mass into length to the power of -3, like that we can write. So here density is a derived quantity. It depends on mass and volume. Mass is a base quantity, but volume is not base quantity because base quantities are length, mass, time. these three only base quantities. So this volume or some more are there in SI system, like luminous intensity, the absolute temperature, like that. Some more, four more are there, but mainly most of the derived quantities can be converted to these fundamental quantities. So here mass is a derived base quantity, we have written like this, but volume is not a base quantity to be written as base quantity. So we are writing as length cube. So these two are base quantities. So density is a derived quantity. We have written it in terms of base quantities. Mass, length cube. It will become length to the power of -3. Instead of mass, this total base quantities can be expressed in, can be enclosed in square brackets, where the symbol for mass is m. It is appearing only one time. So in the power we have to keep 1. The symbol for length is L. It is appearing -3 times. It is appearing 3 times in the denominator part. So we have to write -3. So this density can be written as m1 L minus 3. m1 L minus 3 means the dimensions of density are. So the dimensions of density are, what are dimensions? Dimensions are the powers to which base quantities are raised. So the dimensions of density are 1 in mass, because mass raised to power 1, -3 in length, because length raised to power -3. So density, the dimensions of density are, so 1 in mass, -3 in length. Like that we can represent. So if there are any other quantities like time or any other quantities, the dimensions of that quantities are 0, because they are not present here. So the dimensions of all other quantities will be 0 in this case. Okay, children. So that is the concept of dimensions. So how to write dimensions, children? First, derived quantity to be expressed as base quantities. So then, whatever powers the base quantities are having, that are the dimensions of that particular physical quantity. See, they are asking about dimensions of density, but how we are expressing 1 in mass, -3 in length. In terms of fundamental quantities, we are expressing. Directly, we are not expressing for density. Next, children. Next, we have dimensional formula. Means like this. Whatever we have written here, the density equal to this one. It's an example of dimensional formula. Means the expression which shows how and which of these, which of the base quantities represent the dimensions of physical quantity is called dimensional formula of a physical quantity. Means for mass, sorry, change it as m, children. In square brackets we have to enclose m. For length, in square brackets we have to enclose L. For time, T. Temperature, K. Or sometimes Q. Electric current, A. Or sometimes I. Luminous intensity, in the square bracket CD. Amount of substance, MOL. MOL. Means these are all base quantities in SI system. So all the base quantities in SI system. So if we write mass equal to m, this total expression will be considered as dimensional formula, or the dimensional formula for mass is m, for length is L, for time is T. Like that, for every quantity there will be a specific dimensional formula. In the previous problem, in the previous concept, the dimensional formula of density is m1 L minus 3. Like that. Means how the base quantities are represented, what base quantities are represented, in what way they are represented, that will tell us about dimensional formula. Dimensional formula. Because dimension means only powers, not the complete one. So here for mass 1 is the dimension, for length minus 3 is the dimension, that's all. This complete expression will be called as dimensional formula of density. Dimensional formula of density. Like that, all the base quantities which are in SI system, they will be having specific dimensional formula. We have supplementary quantities also, like radian, steradian, supplementary units there, or angle, solid angle. We have supplementary quantities also, but they don't have any dimensions. For supplementary quantities, there will be no dimensions. Next year. So here. So the dimensional formula of area is M0, L2, T0. What does it represent? The dimensional formula of area is given. What does it represent? What does it represent? So here M0, L2, T0 means it can be written separately as M in separate enclosed brackets, square brackets, L separate, T separate. We can separate the base quantities. Here the mass, for mass we are having power 0, for length we are having power 2, for time we are having power 0. So the dimensions of area is 0 in mass. So all are dimensions of area, so area only. Dimensions of area, dimensions of area. So dimensions of area is 0 in mass, 2 in length, 0 in time. So this information, this dimensional formula will represent. Next. So dimensional formula of volume is M0, L3, T0. What does it represent? So this can be represented in separate square brackets. So dimensions of volume is 0 in mass, 3 in length, 0 in time. Like that we can tell. So dimensional formula of speed M0 L1 T minus 1. M0 L1 T minus 1. M0 L1 T minus 1. 0 in mass, 1 in length, minus 1 in time. Next one. So we have dimensional equation. Means it's an equation obtained by equating a physical quantity with its dimensional formula. It's called dimensional equation. If we write only this part, this is called dimensional formula. But this dimensional formula equals to force. Equating with the physical quantity. This total expression is called dimensional equation. So only powers are called dimensions. Along with powers, total expression is called formula. Formula equating with the physical quantity, complete part is called dimensional equation. Dimensional equation. So here we have dimensional equations for, or dimensional formulae for some quantities, for area, volume, density, speed, velocity. So what is area, children? What is the dimensional formula of area? Area means the main formula is length into breadth. Length into breadth, also one kind of length. So we have length. So we can represent it as L. While writing dimensional formula, length can be represented with the base quantity capital L, repeated 2 times. So L2, we can write it as L square L2. Here mass is 0, time is 0. So M0 L2 T0. This is the dimensional formula for area. And what is the unit for area? Length is measured in mass, meter. Length is measured in meter. Meter into meter. Meter square or square meter. Meter square or square meter. So area children M0 L2 T0. SI unit meter square. So what about volume? What about volume? Volume formula, length into breadth into height. Length into breadth into height. So length, breadth also one kind of length, height also one kind of length. Length into length into length, length cube, or while writing dimensional formula, length is measured by capital L, appearing 3 times. There is no M, M0. There is no time, T0. So dimensional formula is M0 L3 T0. What is the unit? Length unit meter, length unit meter, length unit meter, meter into meter into meter, meter cube or cubic meter, meter cube or cubic meter. So meter cube M0 L3 T0. So next, what is density? Already we have calculated density, mass by volume, M0 L power minus 3 T0. Mass is measured in kg, volume is measured in meter cube, but if it go up, it will become M minus 3. Next one, speed and velocity. Speed and velocity. What is the formula for speed? The formula of speed is distance by time. Distance by time, where distance is one kind of length, time is t, where L1, T1 goes upside, t power minus 1, there is no M, M0. M0. This is the dimensional formula for speed. What are the units of speed? Distance is measured in meters, time is measured in seconds, meter per second, or meter s to the power of minus 1. Whereas, what is the dimensional formula of velocity? Velocity also same like speed, but in definite direction. Velocity formula, displacement. Velocity formula, displacement by time. Displacement by time. So for velocity also, dimensional formula will be same, unit will be same. So M0, L1. Sometimes no need to represent 1. If there is nothing, we have to represent there is 1. M0, L1, T minus 1. M s to the power of minus 1. It is the SI unit. So these are the dimensional formulae of some quantities children and their respective SI units and their general formula. Let's see some more quantities children. Some more quantities. Acceleration. We have a quantity called acceleration. Means increase of velocity or decrease of velocity, or we can call change in velocity. Change in velocity by time. Change in velocity by time. Change in velocity by time. So what is change in velocity means? It is also velocity. It is also velocity. Already for velocity we have a dimensional formula M0 L1 T minus 1. So already for velocity we have a dimensional formula M0 L1 T minus 1. So by time, by T, means T1, it goes upside, it will become M0 L1 T minus 1 into this T1 goes upside, it will become T minus 1. T another minus 1. T minus 1, T minus 1, if we add means m0 L1 T minus 2. m0 L1 T minus 2. So this is the dimensional formula of acceleration. Basing on dimensional formula also, we can write the units. Length, unit is meter. Time, unit is second. m1 s power minus 2. But no need to mention 1. m s to the power of minus 2. Or m by s square, meter per second square. With the help of dimensional formula also, we can write the unit, children. That is about acceleration. So L1 formula, change in velocity by time. Dimensional formula, m0 L1 T minus 2. SI unit, ms to the power of minus 2. Next, momentum. Next, children. Next we have momentum. Momentum. What is the formula for momentum, children? Mass into velocity. Mass into velocity. So because you have to learn all the basic units, children, basic quantities, their basic dimensional formula and SI units, so that in the coming chapters, whatever chapter will come, it will be easy for you to understand the topic. Mass into velocity. Mass dimensional formula m, velocity dimensional formula m0 L1 T minus 1 T minus 1. If you combine both, this m1 m0, it will be equal to m1 L1 T minus 1. This is the dimensional formula of momentum. What is the unit of momentum? Mass is measured in kgs, length is measured in meter, time is measured in second. So kg meter second to the power of minus 1, or kg meter second to the power of minus 1 come down, second to the power of plus 1, kg meter per second, kg meter per second. So that's about momentum. m1 L1 T minus 1 kg meter s to the power of minus 1. Next, we have force. So next quantity means force. Force means mass into acceleration. Mass dimensional formula, mass m, m1, acceleration dimensional formula m0 L1 T minus 2. Because already we have calculated, directly we can use it. m0 L1 T minus 2. Here m1 m0, if we add means it will become m1 L1 T minus 2, m1 L1 T minus 2. Dimensional formula for force. So unit of force is, mass is measured in kg, length is measured in meter, time is measured in s seconds. Kg meter s to the power of minus 2, or it is having a special name called Newton. It is having a special name called Newton. So the unit of force is kg meter per second square, or Newton. Or Newton. When written with complete name, first letter to be small letter, children. When written only with first letter, it should be capital. So force. Force. Next, children, we have impulse. We have impulse. Impulse means force into time. We have impulse, whose formula is force into time. Already force dimensional formula we have find it. Force m1 L1 T minus 2. m1 L1 T minus 2 T minus 2 into T means T1. m1 L1 T minus 2 plus 1 equals to minus 1. So this is the formula for impulse. So if we know dimensional formula of one quantity, we can find the other quantities basing on it easily. m1 L1 T minus 1, where mass kg, length meter, time s to the power of minus 1. So m1 L1 T minus 1 kg meter s to the power of minus 1. Next, work or energy. Both are having same formula. Both are same. Work and energy both are same. Work and energy formula. So work and energy both are same. Formula. Force into distance. Force dimensional formula m1 L1 t minus 2. Distance dimensional formula, distance is length L1. If we add both m1 L1 plus L1, it will become L2 t minus 2. So mass kg, length meter square, time second to the power of minus 2. Kg meter square s to the second to the power of minus 2 or kg meter square per second square. It is having a special name called joule with small letter joule or capital J. Capital J. It can be represented with the name starting with small letter joule or represented by first letter capital J. So work, dimensional formula and unit. Dimensional formula, sorry children. Force. Correct only. Work and energy, force. What is force? M1 L2 T minus 2. Distance. M1 L2, it's minus 2 children. M1 L2 T minus 2. M1 L2 T minus 2. So joule, J small letter. This one. Next one. Next we have for power. This to be minus 3. Minus 3. Next one we have power. So we have a unit called power. Means with what power we are doing the work. Means how much work done in how much time. Work by time. This is called power. In less time we are able to do. Suppose two persons they are given same work. Who will do in less time? He will be having more power. Who will take more time? He will be having less power. So power formula work by time. Work dimensional formula just now we have calculated M1 L2 T minus 2. M1 L2 T minus 2 by time dimensional formula T. So M1 L2 T minus 2. If T goes upside, T power minus 1, which is equal to M1 L2 T minus 3. M1 L2 T minus 3. T minus 3. T minus 3. So R, its unit is, mass is measured in kg, length is measured in meters, time is measured in seconds. Kg meter square s to the power of minus 3, or it is having a special name called watt. Power is measured in watts. Power is measured in watts, small w with single letter capital W, watt. So last one children, pressure. Last one, pressure. The unit of the formula of pressure is how much force we are applying on how much area we are applying. That is called pressure. Force M1 L1 T minus 2 is the dimensional formula of force. Area, length into breadth, means L square. Dimensional formula of area R M1 L1 T minus 2 into L square goes upside L power minus 2. If these two, if we combine, M1 1 minus 2 means minus 1. L minus 1 T minus 2. T minus 2. This is the dimensional formula of pressure or mass kg, length m to the power of minus 1, meter to the power of minus 1, time second to the power of minus 2. This is the unit of pressure or it is having a special name called Pascal, whose symbol is Pa, Pascal. Pascal, or it is also called as Newton per meter square. Newton m to the power of meter minus 2. Newton m to the power of minus 2, or Pascal, or kg m to the power of minus 1 s to the power of minus 2. So this is the formula, dimensional formula, SI unit. So like this, children. So today, so we have learned about dimensions, children. So dimensions means just powers to which base quantities are raised. Dimensional formula means all the terms enclosed in square brackets. It's called dimensional formula. So what does it represent means what are the dimensions in mass, length, time, that all we have to write. Dimensional equation means equating the dimensional formula with the physical quantity. Complete expression is called dimensional equation. So we have so many physical quantities. Based on their general formulas, we can write dimensional formulas, and with the help of dimensional formulas, we can frame their SI units also. But while writing these SI units, the quantities like force, impulse, work, power, pressure, they are having special names. The unit of force is Newton. The unit of work is Joule. The unit of power is Watt. The unit of pressure is Pascal. Like that. Okay, children, let's continue the remaining topics in next video. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website, children, www.aimstoday.in, for previous classes, for English speaking classes, for coding, art and craft, reasoning, for live worksheets, and for attempting quizzes. Thank you, children. Have a good day.